Hey, how are you guys doing? Physical geology students, today is the 18th, but this is the lecture for July the 20th. It's the last group of lectures that we're going to be doing. I think it's going to be called Summer 45. Last time we left off talking about, we already talked about tides. Um, and what we want to do next is talk about currents. And let me see if I can get back here to the book. So we're on chapter number 12. Please don't forget the test is going to be on Wednesday at 7 p.m. And there's a lot of water stuff on there, groundwater and running water. And we left off talking about currents. So uh, this particular map here shows you currents that go around the world. These are surface ocean currents. And if the arrows are in red, that means that they're warm water ocean currents. If the arrows are in blue, then they are cold water ocean currents. Let me see if I get another picture of this for you here. That might be. Story goes back to the Revolutionary War times, and believe it or not, Benjamin Franklin was part of the reason why we discovered ocean currents. And how did that come to be? Well, back in those days, here you can see the 13 colonies were over here, and Britain was over here, and France is over here. Well, you know that Benjamin Franklin was part of the reason why the Revolutionary War ended up being a victory for us, because he got the French on our side. And if it wasn't for the French being on our side, then the Battle of Yorktown might have ended up a lot differently. The British Army could have escaped. And during those times, um, Benjamin Franklin had a nephew living in France, in Paris. And he was working on getting the French monarchy on the side of the 13 colonies. So he would send, there was no internet back then, there was not even telegrams back then. So they had to send ships out from Boston Harbor to Normandy in France, and then from there, the French would send a courier to Normandy and transport the mail to Paris. Well, when the ships went to France, they followed a certain route, and then they followed that same route back to the 13 colonies. And Benjamin Franklin was wondering, why is it that when I send mail out from Boston Harbor, it gets there 3 days faster than the same ship coming back to Boston Harbor from Normandy? The same distance is covered, but it gets to France a lot faster. And observers were sent out on the ship to see why that was, and they said there was a current that they were following to France. And now we call this current the Gulf Stream. You can see it's in red, so it's a warm water ocean current. So that's kind of interesting that because of Benjamin Franklin's inquiry, we learned about the warm water current going off the eastern seaboard to France. Now we know that there's ocean currents all around the world, and the ones in red are warm water ocean currents, and the ones in blue are cold water ocean currents. Notice that the currents move in a bent circle. This is called a gyre, Gyre. So they turn clockwise in the northern hemisphere, whereas in the southern hemisphere they turn counterclockwise. Now, ocean currents have a powerful effect on our planet, making it more livable. What do I mean by that? Well, the way it works, it's kind of like the heat pump on your house. Uh, Warm water is brought closer to the poles. For example, you can see warm water going here past Europe or Japan. These places should be too cold for life. For example, if you take a look at Germany here, Germany is at the same latitude as Canada. So it should be a very cold place. And we know that Germany is not a cold place. Why is it that Central Europe, for example, is a livable place when it should be freezing cold there? It's because of the warm water ocean current that warms the air off of Britain and Northern Europe, allowing them to have a temperate climate. Same thing with Japan. Japan should be a lot colder than it is, but because of the Kurashiro current, which is this warm water ocean current going off the coast, the southern coast of the main island of Japan, Honshu, that makes the Tokyo area temperate instead of cold. In other words, so it's what these ocean currents are. They're bringing warm water to places closer to the poles and making those places livable. Same thing over here in Brazil. You got warm water ocean currents. It should be a lot colder in Brazil, but it's warm because of this warm water ocean current. Now, you might ask yourself, how is it possible that we have cold water ocean currents when we know that cold water is heavier than warm water and it's going to sink? It shouldn't form surface ocean currents. Well, it actually does in 4 important places that we want to remember, and that is off the northwest coast of Africa, the southwest coast of Africa, the west coast of South America, and the west coast of North America. And notice that these cold water ocean currents move towards the equator, bringing cold water towards the equator. Now, the reason why that's important is because that makes life more livable in these areas because the air is cooler here. And it should be much warmer here off of the coast of California, but we have this cold water ocean current cooling the air, so we have temperate climates in California and off of Spain and Southwest Africa and off here of Peru. So what the ocean currents are, they're kind of like the heat pump on your house. They redistribute the temperatures around the planet so that it's more livable near the poles as warm water currents warm the air up there, and it's colder near the it brings cold water to the equator, making those areas more livable. So the ocean currents are very important to life on planet Earth. These 4 places where cold water moves towards the equator are also very important because these are places that geologists refer to as zones of upwelling. What are zones of upwelling? Well, upwelling means, if you think about it, see where these 4 blue arrows are? Cold, salty water is brought to the surface in these locations. Now, this cold, salty water, cold water is heavy. It should sink. It shouldn't make currents, should it? Salty water makes it even heavier, denser. So how is it that cold, salty water is on the surface in these 4 locations of upwelling? Well, the reason why is because of this motion, this circular motion of these gyres. As the warm, clear water moves away, the cold, salty water actually rises to the surface off the west coast of South America, the west coast of North America, northwest coast of Africa and Spain and Portugal, and the southwest coast of Africa. So cold, salty water rises to the surface at these 4 locations of upwelling. And this cold, salty water is filled. Cold, salty water is usually on the bottom, being heavier. And so it's filled with nutrients from all the things that have died in the ocean and added nutrients into that water. So not only is this at these zones of upwelling, you have cold, salty water here, you have cold, salty, nutrient-rich water. Now, what does that mean? Well, that means that these 4 locations on planet Earth The west coast of North America, west coast of South America, northwest coast of Africa, and southwest coast of Africa are the best places in the world to do saltwater fishing, because those cold, salty waters bring those nutrients to the surface and allow for an abundance of biological activity and plankton. Plankton are these microscopic creatures that live in the ocean, and the more plankton you have, the more fish you have. So, because of that, this tiny country of Peru here has a bigger fishing yield than any country in the world because of this cold, salty water here. And we have off the coast of Spain and Northwest Africa huge anchovy and uh, and sardine populations. And off the west coast of North America, we have huge fishing yields because of these zones of upwelling. Wherever you got those zones of upwelling, which are these blue arrows, you get nutrient cold salty water reaching the surface of the earth. The only time when this pattern of ocean circulation changes is during what we call an El Nino. I don't know why I clicked on messages. Sorry about that. That's my mom. Uh, El Nino. So when you get an El Nino, which occurs about every 7 years, then this pattern is disrupted. But during normal years, this is the way the ocean currents move. Quite interesting, if you ask me. Here you can see it. The, the Usually this cold, salty water is going to be on the bottom of the ocean, and so near the poles you form lots of cold, salty water, but it's deep water, and it rises to the surface at those four locations I just mentioned. Next thing we're going to talk about is real estate along the coast. Now, people who buy real estate along the coast, and we're going to focus on the United States here, um, people are attracted to living near the oceans. And as I mentioned before, uh, I think I mentioned it before, is let's take a look at ocean beaches, coastal property for a moment here. Lots of houses are being washed into the ocean, especially when you have high tides, spring tides, and winter ocean storms, especially along the west coast where the headlands are retreating due to sea cliff erosion. So people want to live near the ocean because it's beautiful. I have a friend who lives in Playa del Rey in California on a beach front property. He and his wife and two little girls. They don't have a situation like this, but they have a nice property, and they can walk onto the beach every day and walk their dogs. It's just so beautiful. It's just something about human nature. People are attracted to the ocean. Problem is, our beaches are eroding away. Why? Well, that goes back to what we were talking about earlier on. Dams. When you build dams, sure, there are benefits from dams. We talked about that before. Go listen to the previous video. But there are disadvantages of building dams. Dams cut off the supply of river sand to the coastline. And that, I'd guess 70 to 80% of beach sand is derived from deltas. And deltas are where rivers go into the ocean. So what do you think has happened since the 1850s, and we built dams in 90% of our rivers? We've cut off the supply of sand to the coastline. So in almost all cases, our beaches are disappearing. And that's called beach erosion. Notice that in this particular situation, the house is falling into the ocean. Why? Well, look how narrow the beach is here. What do you think is going to happen when high tides come in and ocean storms come in? They're going to crash into this cliff, making it steeper and steeper. It's so it's mass wasting is occurring here. That's why there's no vegetation growing on this cliffside, because the plants don't even have time to take root. So this, as it gets steeper and steeper, eventually this house is going to fall into the ocean. So the value of your real estate along a coastline is dependent on how wide your beach is. So if you had a wide beach that went out for a couple hundred yards out into the ocean, then you wouldn't even have to worry about mass wasting or losing your property, would you? So the wider your beach is, the more your property is worth. For most American families, the biggest investment you're going to make is real estate. And so if you have a house along the coastline and you have a beach that's 100 yards long in front of your property, then your property is worth millions. On the other hand, if your beach is just a couple feet long, your property might be worth 100,000, 150,000. Therefore, people need people who live along the coast are extremely interested in figuring out how to widen their beaches. If you're if you live in part of the coastline where there's an undammed river or creek nearby, then you don't have to worry about it. But those houses are in the tens of millions of dollars. So, what do people with more ordinary means do to keep their beach wide and protect their property value as well as their family? Well, let's take a look. Um, you can build engineered structures to protect your beaches. I'm going to show you them one at a time. The first thing you can do is to build a groin. G-R-O, a groin. Now, what is a groin? You might not have heard of these terms before, but I'm going to show you. So what a groin is a wall that you build. Let's say here you got this property here, and they decide they want to make the longshore current is going down this way in this picture. That means the sand is moving down this way. Then you just build a wall, and that wall collects the longshore drift from the longshore current and widens your beach. See how that works? So one thing you could do to protect your property is to build a groin, which is a wall to collect sand. So let's say this is your property over here. I'm losing beach. Let's collect some of that longshore drift and widen our beach. The problem with building a groin, though, is what's going to happen to your neighbor then. Your neighbor is no longer going to get most of the sand they used to get. Right? Most of the sand is going to be collected by you. So erosion is going to occur on your neighbor's property. And that's not going to lead to good relations between you and your neighbor. So what here you can see in this picture here, here's a groin, here's a groin, a groin, and a groin. They're perpendicular to the coast, and they've all built these to widen their beach. So if you build a groin over here, your neighbor is going to build a groin to collect any sand that gets over your groin, and etc. So what you end up with is the whole coastline being covered with these groins. See? But you see the problem? If everybody builds a groin, then you're in the same situation as before. This building a groin only works if your neighbor is willing. It only works if no one builds one around you. Then you collect all the sand. But if you build all these groins like this, have you gained 1 grain of sand? No. So more and more we're seeing that building a groin doesn't work. It only works when somebody's willing to take the hit. So people don't do that as much as they used to because it just doesn't work. The next thing you could do is you could build a seawall. A seawall is a structure built parallel to the coast instead of perpendicular to the coast. So you can see that here's a nice seawall made of concrete, and they had a little sidewalk up here. And so to protect this property up here, they built this wall. So the waves, when the storms come in, the waves crash into this wall, and the water's reflected back to the ocean. Here's another seawall that's been built. So you could build this wall to protect your property, and it's parallel to the coastline. It's called a seawall. What's the problem with the seawall? Well, look how narrow this beach is in front of the seawall. Why is it so narrow? Because the waves, when they crash into the seawall, the water gets reflected back into the ocean and carries away sand. So the problem with building a seawall is you lose the beach. See, this place here has completely lost their beach. As the water reflects off of that seawall, the sand is washed away. So what eventually happens is this seawall gets undermined as the sand beneath the wall is removed and the wall collapses. So we found that seawalls are not a great solution. You lose the beach. And what attracts you to living near the ocean is the beach. If you have no beach, your property is not worth as much. If you have a hotel like these people here have, who's going to want to go to this hotel when there's no beach left? So that's going to reduce your property value. So seawalls don't work very well because you lose the sand in front, the beach in front of the seawall. What else can you do? Well, you can use Gavions. Gavions. Okay, now what Gavions are is you can see here's a beach and here's property here. And what these people have done is they've bought these cages of rocks. You can buy them at Lowe's or Home Depot and have them brought to in front of your property. So you make a wall of these rocks. This is a little better than a seawall because when the waves crash into this, they're not reflected back as much. So you still have some beach left. Problem with this is it's very unattractive. People like to see natural beach in front of the property, but it is one thing you can do is buy cages of rocks called Gavions and put them in front of your property. Another thing you could do, and if you do this, you can preserve more of the natural look, is you could buy Riprap. Now what is Riprap? R-I-P-R-A-P. Well, Riprap is, instead of buying cages of rocks, you just get a whole bunch of boulders and put them in front of your property. See how they put this in front of this golf course over here? And this gives you more of a natural look, and the wave energy is broken up by this riprap. In this case, they put this riprap here right in front of this coastal area. You can see them putting it here to protect this road, riprap. Riprap, it's more natural looking, but at the same time, there's still wave refraction going on, so the waves are still going to be reflected to some degree. And you can see in this case, they lost their beach. And if you live near the ocean, you want to have a natural look. You don't want to have something like that. That's not attractive. A seawall and riprap. So the only thing that really works, and we found that the only thing that really works is beach nourishment. What is beach nourishment? Well, beach nourishment means, let's say you have a property and you're worried that your beach is becoming smaller and smaller and your property value is going down and down and down. You're losing equity in your home. And now you're worried about losing your house itself. You can get a contractor to come out and you can buy sand. You buy it by the cubic yard, and they come out with bulldozers or trucks and skip loaders and dump the sand in front of your house. Well, how do you know how much money you need to spend to protect your beach? You need to hire a geologist, a coastal geologist, and he or she will figure out a sand budget for your property. What's a sand budget? Well, a sand budget figures out, let's say, let me draw you a little picture to show you what a sand budget's like. So let's say this is the land and here's the ocean. And here is your property right here. Here's your house right here. And you're worried because you have almost no sand left on your beach. So you call in a geologist and you figure out a sand budget. Figure out how much sand is coming down onto your property every year from the longshore drift and how much is leaving. How much is being blown in from sand dunes, how much is being washed out to sea by the oceans. If you have a creek on your property, how much sand is being added to your beach by the creek. And so you tally up all the numbers. And let's say if the geologist is good, he'll give you a good, an accurate number. Let's say it's 1,000 cubic yards. Well, then you call the contractor in and ask to have 1,000 cubic yards put on your property every year. Because you're going to lose 1,000 cubic yards a year, you need to make it up. Now you need to hire a geologist who knows what he's doing. Because if he tells you an inaccurate number, and he asks you, he tells you that you need 5,000 cubic yards when you only need 1,000 cubic yards, you're going to be wasting a lot of money. You're going to pay 5 times more, and that sand is still going to get washed away. If he gives you a number that's too low, your beach is going to shrink. So you need to hire a reputable coastal geologist. You look online to see reviews and what other people say about his work or her work. So this is the only way that we have found that works. And the buying and selling of sand to protect coastal property is a multi-billion-dollar business. Did you know that more money is brought into the state of California by tourism than Silicon Valley and Hollywood combined? And what attracts people to California is the beaches. So where does the sand come from? Well, we mentioned before that the dams block the movement of sand downstream. So what you have is contractors bidding on the sand that collects in front of the dams, and then they go in and they dig out that sand and they sell it per cubic yard. Talked about the tides. Now, I'm going to start talking a little bit about the next chapter. Chapter number 13. Ou en français, leçon 13. Deserts. Okay, chapter 13. This will be the last chapter we that we're going to talk about. What are deserts? Well, deserts are places that are dry, that have low precipitation 12 months a year. That's a desert. At the moment, 10% of the Earth's surface is covered by deserts. But, so what's the difference between a desert, a steppe, and a dry land then? Well, dry lands include your deserts and your steppes. Deserts only cover up 10% of the Earth's surface, but drylands cover 30% of the Earth's surface. So 20% of the Earth's surface is covered by steppes. What are steppes? Steppes are places that have dry weather 10 months a year and have about a 2-month rainy season. Most famous steppe is Serengeti in Africa. Kind of slow. Sorry. Boy, is that slow. Well, that's a bit too slow, so I'm just going to tell you what a steppe is. A steppe is a place where you have 2 months of rainy weather and 10 months of dry weather. 30% of the Earth's surface consists of dry lands, and there are these red areas here. What is some myths people have about deserts? In this picture here, they say 30% of the Earth is deserts, but it's really deserts and steppes. 30% dry lands. But what are some myths people have about deserts? I lived in a desert for 3 years, and I can tell you that people have a lot of myths about deserts. The first myth about deserts is that they're covered by sand dunes. Only part of the only a small minority of the desert is covered by sand dunes. We're going to talk about the rest of the deserts as well. The other myth people have about deserts is there's nothing living there. There's all kinds of creatures that live in there. They just don't come out during the day when it's hot. And there are a lot of plants that are adapted to living in the desert. The third myth people have about deserts is that they're the main method by which sediment is moved in deserts is the wind. It's true that the wind is more important in moving sand in the desert than in other environments. However, water actually moves more sediment in the desert than wind. And you might ask, that doesn't make any sense. You just told me that it's dry 12 months a year. Well, when it does rain, huge amounts of sediment are moved in the desert. Why? Because there's less vegetation in the desert, so when it does rain, you get these mud flows off the mountains. Huge amounts of sediments are actually moved by water when it does rain. Fourth myth about deserts is that this is useless land. It's not useless land. Many people are used to living in the deserts in the Middle East, and cultures have built, like the Bedouin people in Africa, they rely on these desert environments. Deserts have a beauty to them, like Death Valley. My mother likes to set up her easel and watch and draw paintings. all these surreal plays of colors on the desert. It's quite beautiful in its own way. The largest desert in the world is the Sahara Desert here in Africa. This is not all desert. Part of it is steppe, but uh, almost all of North Africa is covered by the Sahara Desert or those steppes. At the same time, we don't want our deserts to grow anymore because um, we can't grow too many things in the desert. And here in the United States, we're blessed. We have enough to eat. There are people right now around the world, as you watch this video, are starving to death right now. And a lot of problems occur in desert countries when they have very little land that can be used to grow crops. And when the deserts grow and they wipe out any fertile land that's available, like in Yemen, in the Middle East, you have people starving to death. So we need to, climate change is occurring. Global warming is occurring, and it's due to the burning of fossil fuels and the cutting down of trees. Fossil fuels add CO2 into the atmosphere. I'm sorry. Yes, burning fossil fuels adds CO2 into the atmosphere. Trees remove CO2 from the atmosphere. We have less trees now than during George Washington's time. We've cut down millions of acres of trees as the population grows. So we're removing less CO2 from the atmosphere, but we're adding trillions of tons of CO2 into the atmosphere from the burning of fossil fuels. Therefore, the Earth is warming up. You're young. You might not remember. You won't remember if you're young. But going back, talk to the old timers in Tennessee, Minnesota, New Jersey, California, anywhere. They'll tell you that it used to be colder. These high temperatures we're experiencing are not normal. And they're causing the deserts to grow. So we have to find a way to stop the deserts from expanding or growing. Why do we have deserts? Well, there's a variety of different reasons, but this picture here shows you the main reason. There's 3 other reasons besides this main reason, but let's take a look at wind patterns across our planet. And we also need to know what a low pressure cell is in meteorology and a high pressure cell. You ever watch the weather forecaster on TV, and when she goes and she shows something like this on a map, there's a high pressure cell over Knoxville, or there's a low pressure cell over Knoxville. What is a high pressure cell? A high pressure cell means that hot, dry air is sinking. As air sinks, it heats up. Why? Well, the reason why, imagine an old-fashioned bicycle air pump. And if you push down on that pump and you put your hand around that barrel, you notice how it gets warm? Because as air pushes down, it warms up. I'm not going to go into all the details. It's called adiabatic heating. But sinking hot, dry air is formed by high pressure cells. When the weather forecaster says a low pressure cell is moving over Knoxville, it's just the opposite. That means warm, moist air is rising. And as warm, moist air rises, it cools down because it gets colder at higher altitudes. So which of these 2 pressure cells, high pressure or low pressure, do you think is going to make rainfall? Low pressure cells make rain, ladies and gentlemen. So next time you watch the weather forecast, look at what the weather forecaster is saying. If she says a low pressure cell is occurring, it means rain. If high pressure cells over the area, it means hot, dry weather. Now let me ask you another question, and you should be able to answer this based on common sense. Where do you think, what kind of pressure cells do you think you're going to find over deserts? High pressure cells, right? How about over rainforests? Low pressure cells, right? Okay, keep that in mind as we look at this diagram. Here you can see the equator. And here you can see latitude 30 degrees north, latitude 60 degrees north, and all the way up here on the North Pole. Here you can see 30 degrees latitude south and 60 latitude south, and that's the South Pole. Let's get our bearings here. This area around the equator is filled with low pressure cells. That's why we have rainforest near the equator, warm, moist weather, and luxuriant vegetation. Why do we have low pressure cells near the equator? Well, we have what affects the climate near the equator are the winds. South of the equator and north of the equator, we have the trade winds. And the trade winds move towards the west, and they converge towards the west. So when two air masses collide, like two freight trains colliding, the only way to go is up. So when you have converging air at the equator, you're going to form warm, moist air rising and low pressure cells near the equator. That's not where we find deserts, is it? Okay, now let's take a look at 30 degrees north and 30 degrees south. You probably remember from geography that this 30 degrees north area marks the Tropic of Cancer. The 30 degrees south is the Tropic of Capricorn. Well, in these mid-latitude areas, this area is affected both by the trade winds and the westerlies, which exist towards the poles, closer to the poles. The westerlies move in the opposite direction of the trade winds, so they move to the east primarily. Therefore, if you are in these subpolar areas, if you're at the Tropic of Cancer or the Tropic of Capricorn, 30 degrees north and 30 degrees south, you have diverging air. In other words, you have air moving away from each other. When air moves away from each other, then it forms a gap and the wind above can sink down. And as it sinks down, it heats up. Therefore, you have high pressure cells here at the subtropics. These are called the subtropics, the Tropic of Cancer and Capricorn. High pressure cells and hot, dry air sinking. That's why, ladies and gentlemen, that at the subtropics, the Tropic of Capricorn and Cancer, that's where most of the world's deserts are located. Most of the world's deserts, in summary, occur due to diverging air from the westerlies and the trade winds, forming high pressure cells at the subtropics. We go to 60 degrees north and 60 degrees south, much colder, closer to the poles. Again, you have converging air because you have the easterlies, which move west, and the westerlies moving east, and so then they start to divert and they come together, so that you have converging air here at 60 degrees north and 60 degrees south, and therefore you have lots of snow and ice up here. But where most of the deserts occur at the subtropics, 30 degrees north, 30 degrees south, due to diverging air and high pressure cells. That's the reason for most of the world's deserts. We'll talk about the other 3 reasons for deserts in the next video.